Cengage Learning is a leading provider of innovative teaching, learning, and research solutions for the academic, professional, and library markets worldwide.
Which will talk about build, measure, learn from the trenches, Kanban and Lean Startup, making the most of both. And Alexey is a software engineer who has 15 years of experience and focus on agility, and he's interested in lean systems and in Kanban and software development, IT, other types of knowledge work. And not only he creates software, but he coaches, trains, consults, everything around Agile, and he frequently presents on Agile and Lean, and he lives in Waterloo, Ontario, Canada, which is a hotbed of software development. And he's the organizer of the local limited work in progress, Waterloo Information Processes.
Yeah, Limited WIP Society.
What's WIP?
Work in progress.
Work in progress, okay. A group that could be a lot of things. Group dedicated to spreading knowledge and practical advice on Kanban. So now, Alexey, please.
Marina, thank you very much for the introduction. I have a very long title for tonight's talk because it is actually two titles, and I just couldn't decide between them, so I just combined them into one really long title. So I will talk about two new, can we call them methodologies or mindsets, known as Kanban, that's one of them, and Lean Startup, that's the other. What they are, how they can be combined, how they relate to each other so that we can make sense of them and find something useful in one or both of them or some combination of them that we could use in our daily work. Build, measure, learn refers to kind of the operating mode of the Lean Startup, and I want to talk about that a little bit from my own experience in the trenches, so hence the title. Both titles are obviously borrowed from Henrik Nieberg's books, you know, Scrum and XP from the Trenches, respectively, and Kanban and Scrum making the most of both. So Kanban and Lean Startup represent two new approaches to develop software, develop other kinds of technology, do all kinds of information technology and other knowledge work, and build successful technology businesses. You can probably recognize the two foundational books on each of these two concepts. David Anderson Kanban book and Eric Ries's Lean Startup book that were published respectively in 2010 and 2011. And you can possibly recognize the social media avatars of those two people. Before I proceed, I'd like to ask you several questions. What do you expect to learn about either Kanban or Lean Startup tonight? Do you have a question that you really want answered? And I'll try to answer it during the presentation. Yes?
How do you bring a Lean Startup mentality to older, more established companies?
definitions.
Quick.
Quick definitions. Excellent.
How do you keep a startup from staying? How do you maintain focus in a startup using these methodologies?
I'd like to also start with another set of questions. How many people? I just want to understand the level of existing understanding of Kanban and Lean Startup. So, how many people work in teams or organizations that actively practice Kanban? Several. And maybe heard something about it, know someone who uses it? Probably many more people. Great. What about Lean Startup? Okay, well, Lean Startup, the book, Eric Ries's book, was published actually less than a year ago, so this is a really cutting-edge stuff. So even though these two books were published very recently, they represent the summaries of work that took probably more than a decade for both of these two visionaries. So in case of David Anderson, it goes back to the Agile 2007 conference when the existing Kanban movement started with his presentation of case studies of initiatives that he led at Orbis and before that in Microsoft. But those initiatives took place from 2004 to 2007. And before he got into a position to start something at Microsoft in 2004, there were several years of experimentation with limiting work in progress in other companies. In case of Eric Ries, he is, of course, now very famous, and his book is a bestseller, and not just in the technology field, but overall. It also took him about 10 years of experimentation, of successes and failures, of trying to start technology companies after the dot-com crash. And he learned a lot, and he summarized his learning in the book that he titled The Lean Startup. And that's how he became the pioneer and the leading advocate of the Lean Startup movement. So in order to understand some of the concepts and principles, I want to go back 10 years and tell a little bit of my own story. Actually, I should have mentioned, I'm somewhat of a kind of international man of mystery, kind of the Russian guy who came from Canada to Boston, and this is like a homecoming because I used to live in Boston, and it was between 14 and 10 years ago, and actually some people that I knew in those years are in the audience tonight. I'm really thrilled about an opportunity to be here in this area and present. I worked at a couple of companies on 128 in Bedford and Burlington, just a few exits up on the highway. And what happened 10 years ago, it was just my family situation, also kind of combined with the work situation that I worked in a company that was building a product that nobody needed, and so the end was near, and my wife got the job in New York City, and so we moved. And So that was the time when I was schooled and experienced in software engineering. I kind of knew how software gets created. Actually, this picture is not entirely accurate because it, leads to a certain methodology of software development, but the reality was a little bit more nuanced. Actually, at my last job here about 10 years ago, we did have releases roughly every 3 months, so it wasn't like build big design up front and then 18 months later we find problems. And also, what I knew about creating software back then had a lot to do with kind of a siloed view of just designing and implementing code, whereas delivering software takes a lot more effort than that, and that was just something handled by other people, whereas my focus was on designing and implementing it. And so 10 years, I moved to New York City and I joined a startup unexpectedly. It was an internet startup. The company had only about 25 people, and we had about 4 software engineers, like 4 people who could write any kind of code. Everything else was business, marketing, advertising, operations, and sales. The company was started by people who were foreign to software engineering. They came from Wall Street. They made some money, and they just wanted to invest it, and starting another hedge fund wasn't a profitable proposition in 2002. And well, several years later, I heard one of them saying we should have invested in real estate. But they decided to invest in an internet startup with a heavy software development component. And so there was a small group of engineers that I joined that had to make it work for very demanding customers. Well, we had to treat them like our customers, right? Even though the company had real customers, real paying customers, and also end users who were different people, by the way, as it often happens in the field of internet advertising. So what these founders were very clear about was that they did not want to create another .com. How many people have worked in what can be described as a .com? Really, quite a few. So a typical .com has a 90% chance of a total burnout, complete write-off for investors and founders, and employees just have to find another job and just give it another shot. With a 90% chance of failure. With about like single-digit % failure, there is some degree of success, some payback, maybe an IPO, maybe a buyout. Investors get some return of their money. Employees keep their jobs for a while. With a probability of 1% or less, the startup hits a home run. Investors become millionaires. Some of the employees too. But it was essentially a casino. And after the .com crash, some entrepreneurs, and Eric Ries was one of them, he's the most famous now, but he was not the only one at the time, who started looking for ways to do better than that, to get the kind of the gambling element out of starting up businesses. So what the founders wanted, they didn't want to build something and they hope the customers will come. They wanted kind of a greater certainty of success. And so the 4 of us had to answer all kinds of demands that they had. So we did all kinds of things, such as helping them specify features. We were always involved actively in deployments. Intense collaboration with the various business stakeholders, people like I never had the chance to collaborate before I suddenly started having like daily meetings with. We measured and quantified a lot of things that happened after the deployment of the software, and tried to learn from it. Okay, so what is not mentioned in this picture is that we also designed and implemented code. That kind of goes without saying. And today we might call it DevOps. There was not a term for that back then. There were no terms like lean startup, although this was somewhat lean startup-ish company. And I don't think I even knew the word agile back then, although I did create my first test double and my first human readable acceptance test back then. Oh, there was also this. Lots of statistical information that somebody had to process, and it was usually us, the engineering people, with some remaining knowledge of math or statistics from our college years still in our heads. At least we had more of it than most of the business people in the company. So we had to do that as well. And most importantly, our business learned from statistically validated results. So for example, if we had a new advertising algorithm, we would ask, does it increase click-through rate in the travel category as we thought it would? By how much? Oh, let's say it's 50%. Okay, can we sign JetBlue as a client, for example, because of that, or some other regional airline if we have precise targeting their markets? So our business leaders learned from that kind of knowledge that was generated on a continuous basis. That was the most important part. And today we call it build, measure, learn. So this is the main kind of operative loop of the lean startup. We build a product, we deploy it, we measure and quantify how what users and customers do with it. We get some data, we learn from data, we get new ideas from that data, and then we build again. So this diagram is essentially one of the classics of today's lean startup movement. Build, measure, learn. Build product, measure, get data, learn, get ideas, and build again. Get through this loop as quickly as possible. This is how lean startup is described today. We did not have this diagram back in those days, but this is what we did. Now let's fast forward to today. It's a very different time. What did I learn from those years that is useful today, now that we have all these words like lean startup and Kanban and agile and so on? And I think it's this. Regardless of what you may have heard about lean startup or seen or tried, I think it's about this really big problem. How to design systems that can continuously produce validated learning for an organization's founders and business leaders. The lean startup, as it is currently presented in many books, articles, blog posts, conferences, lean startup machine events that some of you may have attended or heard of, primarily deals with the consumption of validated learning. how you as a founder, as a business leader, consume this information so that you can guide your startup from one pivot to the next to ultimately discovering the scalable business model. I believe this perspective is sufficiently covered, and today I want to talk from a contrarian engineering perspective. How do we produce that information? Or more importantly, because it's produced differently in different contexts, how we can design systems that work in our respective contexts that can produce validated learning.
Question.
Yes.
Is validated learning synonymous with objective measurements, or does it mean something else?
It means something else, I think, mostly. A lot of business plans are based on assumptions, and validated learning, the purpose of validated learning is replace those assumptions with facts. So if we can learn that a certain percentage of customers make certain decisions in certain situations, and we replace that as a fact, we substitute it for some assumption in our business plan, then our chances of success and of that business plan tend to increase. So gradually producing this learning and plugging those holes in the business plan, and then turning it into reality, and not taking risks that those assumptions will turn out true is what it's about. What I'm going to talk about tonight mostly is how do we produce that information. And I think we, by the way, I forgot to ask also, how many people in this audience can describe themselves as engineers? Software engineers, software development managers, testers, test managers, lots of people. Marketing, sales, great, business development. So I think our experience at tackling very hard engineering problems, and I'm sure everybody who just raised their hand several seconds ago has solved many difficult engineering challenges in their career. I think that prepared us well enough to design systems to produce not products and features, but also validated knowledge. First, I want to give you several kind of teasers about what I see as a possible solution or possible ingredients of such solution, and then we'll treat this subject more systematically so we can arrive at those solutions logically. So one of the teasers is I think that Kanban is a gateway to solving it. Much more than just a method to manage software development work or IT or improve it. It can lead us to it. Why do I think so? Why is Lean Startup called Lean? Why did Eric Ries choose this adjective to attach to the word startup, to name his book and his movement? Is it because he saw, oh, these .com era startups, they overspent on Super Bowl ads, on expensive Aeron chairs, on massages for their developers, on fancy coffees. Okay, now let's put them on a lean budget. No Super Bowl ads, no massages, no cheaper chairs. Is that why it's called Lean Startup? No, probably for some other reason. Actually, for the same reason lean manufacturing is lean. A lot of things that have the word lean in them have a limited work in progress full system somewhere inside. And that's what really makes them work. So somewhere in the lean startup there must be a Kanban system. Where is it? We'll find it. The build measure loop is not so much a loop, but it's a value stream that ends with the delivery of validated learning and begins with an idea to build a product and then measure how users use it. And that Kanban system should be optimized for response time because that's what founders care about. How do we unroll this build, measure loop and present it linearly as a value stream is an interesting question. We'll talk about it in a minute. Now, I can hear a critic here, and a fairly authoritative one. What about customer development? Actually, when you hear about Lean Startup today, you will probably see words customer development in the same sentence. And this is not what I want to talk about today, because I think that's adequately covered, and there is much more to Lean Startup than that. Steve Blank, the customer development and Lean Startup pioneer, kind of his famous phrase was, there are no facts inside the building, so get the hell out. So what this means is, as a business leader, as a founder, entrepreneur, you want to learn about, you want to discover your customers, the products that will delight them. In order to do that, you have to get out of the building and meet with them and talk with them face to face. And you will achieve nothing by trying to build something inside the building and then sell it to them. Well, I'm sure Kanban users will recognize this pattern. And I, of course, several years later, I have the convenience of cherry picking just the right moment of my own experience of working as an engineer in the startup, when we built lots of stuff. The measure phase was our bottleneck. And our business was learning nothing. And if you can remember the cover of David Anderson's Kanban book, it's exactly the same picture. Now the question is, can we do something about it? Well, that takes an act of leadership, and that act of leadership has to come from within the building. Because if you're outside the building, you are not even going to see this board. And yet, if the board is in this pattern, and we let this pattern persist, then there will be no validated learning for our leaders, and there will be no Lean Startup. So several people asked to give quick definitions of Kanban and Lean Startup, and so the next 15 to 20 minutes may very well bore some of the Kanban experts in the audience, but I do want to go through those definitions very quickly, just to make sure that everybody's on the same page and the rest of the presentation is interesting to everyone. So first of all, Kanban changes the thinking about product improvement. So the biggest contrast between traditional and Kanban thinking, and traditional somehow includes agile in its most popular form, which is we take some existing process and we find out that somebody else is doing a much better process and with much more success than we do. So how would we get rid of our existing process and replace it with their process, which is better, which should be better, right? Let's retrain the employees, let's implement a new process, and we'll be successful. That's the assumption that is taken in many organizations. That it's just how it usually works. The Kanban method proposes the evolutionary change. So the successful evolutionary change for your technology business is the subtitle of David Anderson's book, and the key word here is evolutionary. It's a one-word description of the 4 principles of the Kanban method, which the first one is start with what you do now. Do not replace your existing process with anything. Agree to pursue incremental evolutionary change and initially respect the existing process, the existing job titles, responsibilities, and encourage acts of leadership at all levels. Kanban has 6 core practices. Number 1 is visualize. Visualize the value stream, which is kind of an abstraction of a journey of some work item or a valuable feature from conception to completion, to its delivery to the customer. So we start with where it ends, with the delivery of something, and then we trace it back to where it starts, going through several processing steps or dominant activities, and then each activity maps onto a Kanban board. And so the result is a huge variety of Kanban boards, usually rectangular. And yeah, the variety is never ending because each team's process, each organization's process is different. Each work item has a somewhat different value stream. So the result is this never-ending variety. The second practice is to limit work in progress. The famous phrase by David Emerson is "stop starting and start finishing." So work in progress limits mean you do not start more work if you are at the limit, and such as in this very simple diagram. So this column has a limit of 3 and has 3 cards in it. 1 card gets done. This kind of creates emptiness. We are now one item under the limit, which means we can pull item from the left if it's done. Let's say it is done, so we're pulling it here. Now this column is now 1 under the limit, so we can talk about what item we want to pull out of the backlog and start working on it. So the work kind of goes from right to left. So first we look at the right side of the board and think about what we can finish today, as opposed to looking at the backlog and asking ourselves what can we start working on today. Limiting work in progress has certain impact on the cycle time. When you have less work in progress, your cycle times tend to be shorter, thanks to this fact from the queuing theory known as Little's law. And by the way, this is kind of a very interesting example of a Kanban board. So once this team started limiting their work in progress, it would improve quite a bit. Measure and manage flow. So in Kanban, what we want to do is establish a very smooth flow from start to the end of the value stream. So this is done using things, for example, like things that are called classes of service, classified by cost of delay. We measure cycle times and lead times in Kanban, and they kind of inform us about our attempts to manage the flow of work or not. Making explicit policies about what does it mean this is done, or if we were to pull something, how can we decide between several different classes of items. Essentially, Kanban sees the existing process as a set of policies that are collectively owned by the team. And the policy is very simple. You can just write it on the card, put it on the board. If it needs to change it. Develop feedback mechanisms. Kanban produces a huge amount of statistical information that can be visualized using the cumulative flow diagrams, or statistical process control charts, and so on. Like this is, by the way, and not a very healthy looking cumulative flow diagram. This is a cumulative flow diagram of a team that struggles with limiting their work in progress. This one is much better in that respect. This is, some people might recognize that this is actually from the Get Kanban game. So this is a simulated Kanban project. Interesting that the goal of this game was to maximize throughput, and the result was that you have to put up with some unpredictable cycle time. So the response time and throughput can be conflicting goals. Kanban makes it very visible, and then you have to decide what's important to your business. Improve collaboratively using models and the scientific method is the last officially stated core practice of the Kanban method. What kind of models are there? Well, there is a great book about quantitative models by Donald Reinertson. How many people have read this book? This is essentially the physics of software development, like very rigorous scientific treatment of the subject, and lots of useful models that can be used for improving the flow of work through software development and IT organizations. The theory of constraints and what to do with bottlenecks is a great source of improvement ideas that are practiced in the Kanban world. So is systems thinking, and actually some of the approximations of those models can be found in popular books by Mary and Tom Poppendieck on lean software development. Highly recommend. Okay, let's quickly go over reminders of the Lean Startup. So the main thing about Lean Startup is that we no longer define startup by its size or age. So it's not just a company, a private company with 50 or fewer employees founded 3 years ago or later. Entrepreneurs are everywhere. So the Lean Startup is really a mindset as opposed to a reference to the company's size and age. The Lean Startup mindset can exist in any kind of organization. It can be one person's career, it can be an actual startup in the traditional sense, it could be a giant corporation, it could be government. The main thing that all organizations that are in the Lean Startup mindset have in common is that they all seek to conquer uncertainty and find sustainable, scalable business models. Entrepreneurship is management is the second principle of Lean Startup. What this means is a departure from the idea that entrepreneurship means two guys in the garage invent something, like two geniuses, invent something crazy, get some crazy idea, build something, and then they hope to sell it, and then first nobody sells it, and then suddenly it sells for $1 billion. Entrepreneurship, according to the Lean Startup definition, is something that you do systematically, so something you can manage. How you manage? Because it's about accumulation of validated learning. By accumulating validated learning, you substitute assumptions in your business plans with facts, and that's how you reduce risk and improve chances of succeeding. So for example, this is my Android phone, which has lots and lots of features, but it is also a really fancy tip calculator. And so in this picture, this is an episode from the last season of Seinfeld, when Jerry bought a present to his father for birthday. So he bought it for $200, and it was some kind of personal organizer. Remember, the year was 1998, right? So it was well before these fancy smartphones. So you could record contacts there, phone numbers of your friends, your calendar. You could program it so that it plays a certain tune when you need to take your medicine, as Jerry explained to his retired father. He had to take his medicine at a certain time. And Jerry's father totally doesn't understand any of these concepts. But he sees one valuable function. He's in the restaurant and he wants to calculate his tip. So what does this mean? Building this device with so many functions that turn out to be useless to the end customer. Whereas you can build the device with just one function for a lot less that can actually be useful to Morty and his retired friends. And it turns out that they all go crazy over these tip calculators. The problem is they cost $200 to build as they are designed, and so they go with $50 knockoffs, and it all ends badly, as as most Seinfeld episodes do. And Kramer is defeated as a candidate for condo board president. He loses to the guy in a wheelchair, and then he decides to unretire and move back to New York. So Jerry says it does other things, and that's a big assumption. Nobody needs those things. And the validated learning is that this is just a tip calculator. Tip calculator is the real thing. Innovation accounting. So the lean startup needs some way to account for its learning. So it's not just about counting how much money we have or still have, is what we've learned. So we have to account for that. So once the accumulation of knowledge kind of reaches the point when it produces diminishing returns, it's time to pivot. So time to take a turn in the direction which we develop our business and just do something else. So this is the point when we have to abandon our plans of this digital organizer and just do something else. Perhaps an Android app or something. Because nobody would spend $200 on a tip calculator. And the build, measure, learn. This is the final lean startup principle. So this is kind of the outline of the iterative cyclical operation that produces validated learning. Again, we build a product because we have some idea, but then we measure what people do with it. We get some data, we learn from data, and then we get reviews. So that's about it for the reminders about the Kanban method and the lean startup. And now I want to match them up. And now I want to go back several years and reread the 5 principles of the lean startup in light of those past experiences that I talked about. And so what I see is the first 2 principles are not very important, not really actionable. They simply describe what lean startup is about, and we kind of get it over. Validated learning is a very important principle because it answers 2 questions. What is being produced and who is the customer? What is being produced here is no longer a product or a software feature or an IT project. It's a unit of learning. You think of it as bits. What have we learned from doing this? This is a bit of learning. This is our product now. Who is the customer of that product? The customer of that product is the founder of the company, the business leader of the startup, who can consume these bits of validated learning to guide the startup. And what is a build, measure, learn? That's the outline of the value stream that leads to the delivery of the validated learning. Now that we have specified the value and its ultimate customer, and identified the value stream, those two things are the first two principles of Lean. Now we know that Kanban can help. Yes?
Is validated learning equivalent to learn and build, measure, learn? Or is that the incident to that, or separate?
They are stated as separate principles, but they're very closely related. Validated learning, when we say that, we identify what is being produced. We specify the value, which is the first principle of Lean. The build, measure, learn is a very short description of how we produce validated learning. It's the outline of the value stream, which is the second principle.
Thank you.
So let's map a very simple value stream. So validated learning is the endpoint of the value stream. This is what we are producing. Our customer is the entrepreneur who is leading our startup. This is how we apply the third principle. And now let's trace it back to where it starts. Build, measure, learn is the fifth principle. It gives us an outline of the value stream. So we start with some hypotheses, some unproven theories, assumptions to be replaced with facts, and then we build, measure, learn. Now this is a very rough outline of the value stream, and in real life it looks a little bit more complicated. So I want to go back to the startup, to the New York startup that I talked about earlier in this talk, and give you an example of what it worked, how it worked back then. So I want to skip the boring parts of it, which were about how we actually built the product. So that's just software development life cycle. So we just built it somehow. Interesting things began when our product was ready for release. So this kind of complicated diagram describes the measure and learn parts, the interesting stuff. So the very first phase that we were in after the product was ready for release is making sure that the next day does not start with our vice president of advertising operation yelling at everybody in the company, dude, where's my revenue? Because that revenue magically evaporated on the first day after the release because, it just behaved that way that, users, didn't see our ads or didn't click on them or something like that. So, it was like a real concern that might happen, and no amount of testing before the release could actually deal with it. So we just had to test for that in the field. So we typically ran small-scale experiments by rolling out software to less than 1% of the user base, very few users, and did controlled experiments to make sure that the new version and the old version just do the same thing, and we still have our revenue, it didn't go anywhere. Once the statistical information came in over like 24 hours usually, our confidence grew, and this activity was displaced by another dominant activity simply because it began to fade because it produced diminishing returns. You see that basically our null hypothesis is true. There is mounting statistical evidence of it. So can we move on to something else? Well, we moved on to quantifying improvement. Here, our hypothesis would be, we've got a new advertising algorithm, a new way of linking browsing context to ads. Can we get higher click-through rate in the travel category? Can we? How much is it? Is it statistically significant? So we would run certain ads, release software to more users, run certain ads that would let us conduct such an experiment. So there would be several experiments of that sort. We would learn that, for example, it increased by 50%. Then we'd get to the most interesting phase, when we roll it out to a very large number of users, sometimes the whole user base. And then the business would learn, can we actually turn that knowledge into more business and sign more customers? For example, if it was related to travel, can we sign more airlines or hotel chains as our advertising customers? Because of quantified improvement. And that was, again, a null hypothesis, and if it's just we can't prove it, then there is no validated learning in it. So interestingly, that these three activities were all highly collaborative, and each had a very different collaboration pattern. In the first activity, our experiments typically involved a core product engineer, such as myself, our VP of advertising operations, one of the senior ad campaign managers, usually like kind of a server guy who dealt with like the data center and back-end operations. And we just worked together to carry out those experiments and process results and learn collectively and communicate it to our executives. In the second activity, the collaboration pattern shifted. So I was, let's say, still involved as like one of the leaders of those experiments, but we had to run some ads that just weren't possible with the previous version of software. So we had to build them. So we brought in the creative director, a graphic designer, and so on and so forth. So it was a different collaborating team carrying out the second activity. And finally, in the third activity, the role of the technical people kind of faded, and then sales people would come in and get more involved. So throughout this process, it was shifting collaboration patterns and no handoffs. Now, if we were to project this onto a Kanban board, it would look like this. So the initial state is ready for release. The final state is validated. This is kind of a done column. And just 3 columns in the middle representing different activities. So if your hypothesis is here or here, the card is there, and that's just basic visualization technique of the Kanban method. Now, that was the measure learn part. I said the build part was boring. So this is just a straightforward process. Specify the feature, then develop, then test, and some user acceptance test, and then it's ready for release. Now, if we join these 2 boards together, we'd get a board that looks like this. This is what we want to build. Here we're building it, 4 activities, now it's ready for release. And then we are measuring and learning, 3 more activities, now it's validated. And so this is the combined build, measure, learn Kanban board with 7 activity columns. Okay, so now I'm going to say something that's that may disappoint a number of people, and some people will find this like crazy. But I'd say that this diagram is not useful the famous build, measure, learn diagram. Because this is a 40,000 foot view, and it's useful to one person per company, who is the chief executive. And if you want to understand anything about what actually goes on, you need to develop 30,000 foot views, which should look like this 7-column Kanban board, or perhaps 20,000 foot views that would look a little bit more nuanced than that, and then you can apply what you know about Kanban to improve it. What would be your optimization goal in this Kanban system? I contend it would be the response time rather than throughput. Why? Because we are not producing features here. We're producing learning, and the customer of validated learning is our CEO, our entrepreneur, who is looking for the next pivot. So the CEO wants this validated learning as soon as possible, rather than at the greatest rate of accumulation. So the response time trumps throughput in the lean startup environment. And now I want to go back to the big problem that I stated at the beginning. How can we design systems that can continuously produce validated learning? And I want to offer not a complete solution, but some ingredients of such possible solution that could be a little different in each context. First of all, I want to start with red-blooded humans. So this is first of all, it's a human, complex, networked, adaptive organization. This is not a machine where we conquer work by dividing it into chunks, giving each chunk to a selfish human being, motivate them with the motivator that works because they're selfish, count on them to get it done, and then we put these chunks together into the whole thing that we produced. So that is kind of an outdated thinking that cannot possibly solve that big problem. So we need to understand the human nature. We need to recognize all our co-workers, all members of our lean startup organization as human beings. We need to understand what motivates them. We need to understand that human nature is both selfish and also there is the unselfish side. And we need to figure out how to use both to create a system that is a human organization that can collaborate and work together to produce validated learning. The second important ingredient is complexity. So lean startup deals with an awfully long value stream. Build, measure, learn is an awfully long, complex process. All we do in Agile and traditional software development processes deal with just the build part. So waterfall is about build. Rational unified process is about build. Agile, in general, XP, Scrum, and the Kanban process is, iterationless processes. They are all about the build. And we start with feature requirements and turn them into implemented features. So lean startup is that, and then two more things. Longer value stream means this is a significantly more difficult optimization problem than just optimizing the build part. However, because all of us who are in this room today have some Agile experience, we can use experiences of optimizing this part to deal with these, with a more complex system. Everything we do here, as far as Kanban or Scrum or XP, makes us stronger and more prepared to tackle a more complex problem. Another part of this complexity, I just want to reiterate it, is that it doesn't really help very much to see the world in kind of these simplified diagrams with 6 circles and arrows. So we need to dig deeper and develop more nuanced knowledge of our systems. And so let's start with this 30,000 foot view and then get down to 20,000 feet and further. So this picture is pretty much, I'm crossing it out for everyone except one person per company. The third ingredient I want to propose is awareness of local optimization. So practices refined in the build context. And here I have to take a stab at some sacred cows such as test-driven development or specification by example. Refined in this context, you may find that they are suboptimal over here. So you may find an interesting, just totally fascinating question here is, should I TDD my minimum viable product? Well, the answer is it depends.
When they crash for the customer?
Sorry, can you say it?
What I said was, if you don't do it, you risk it crashing for your customer.
Yes, but if I do it, then I risk putting a lot of effort in the product that will lead to the validated learning, which is nobody needs this, so I'm throwing it away, so I risk.
You won't know if it crashed. It may be the greatest thing. It crashed because you didn't test it.
Okay.
I would argue that this whole cycle, build, measure, learn, is in fact an Uber test-driven development, which includes the marketing and sales cycle.
And that it works for any company, not just Lean.
Right.
It's the things we always say we're going to look at, but never actually do.
That's because it involves actually talking to sales and marketing.
Well, good management, who come from quantitative business schools where they teach this kind of stuff. This is standard things.
Yeah, I'd say in New York, I met so many Wharton MBAs who sure read like Goldratt's The Gold as like part of their standard curriculum that were completely clueless as to how to apply it in knowledge work. So I would not rely on standard curriculum of MBAs to carry this out. I think this is more of an engineering challenge than a business challenge.
There's whole companies that have built their business model on this process.
So another thing is that I want to offer as an ingredient of the solution is what I call the upstream mentality. So in the old world, and this is like where we find ourselves a lot as engineers, is that we are usually somewhere downstream, and we are usually the bottleneck. So there is this business on the left, and they have demands on us. They have so many great things that they think are valuable, and they want us to build them. But the thing is, we are the bottleneck, so we can only build so many of them. This is something I want to contrast with the kind of the new world pattern, and this is where I consistently found myself in the build, measure, learn environment, that we are actually here somewhere upstream, and bottlenecks are elsewhere. Just if you are at the most upstream step in the process, then there is a good chance bottlenecks are elsewhere. And it just happened so many times that we just couldn't measure something, or we learned something, but like scaling it didn't work very well in our business departments. A quite typical example of this situation are the large batches of developed, tested, deployed features waiting for users to be trained to use them. And here you are, a developer, engineer, upstream, can be producing more waste, more features that will only increase the wait time of those features for their ultimate users to be trained to use them. And when you are here, you are much more likely to subordinate your activities to the exploitation of downstream bottlenecks. So in my personal experience, I found that sometimes we build features into a product that would make absolutely no sense to build if we had our customers and end users in mind. Those features were there strictly for the purpose of widening bottlenecks. They helped us measure faster and learn faster, and that was their whole purpose. It made sense to build them. And finally, last but not least, Slack. Slack is a good thing in general. Why? Because of this queue size curve. So you can see how it kind of goes up after the 0.8 mark. So what does this curve represent? So suppose you model your software development organization as a system that has a queue of feature requests in front of it, then it processes those requests at some rate and turns them into developed deployed features. If requests arrive faster than the system can process them, they queue up. Because there is a variability in arrivals are kind of random, and the processing is a little random. It varies. You might ask, okay, what would the size of that queue be on average? Well, it turns out there is a formula for it that ties the ratio of the processing rate and the arrival rate, known as utilization, to the queue size. And when utilization approaches 1, the queue size approaches infinity. And when it exceeds about 80%, then the queue size really starts to grow uncontrollably. Essentially, if you have 100% utilization, it's like, with your personal computer, how responsive it is when its CPU is utilized 100%. It's not responsive at all. So the same thing happens in organizations when they have utilization close to 100%. They have an uncontrollably growing queue of requests in front of them. So maintaining a healthy utilization ratio, such as around 80%, is a good thing in general. It is doubly important for a lean startup because the response time is the optimization tool. So it has to be particularly responsive. So that means it has to be a little even further to the left on this curve. So this means a lean startup would have typically more slack in its system than a typical technology organization that is concerned primarily with building products. And actually, I highly recommend this book again that presents this and several other models of product development flow in great detail and with great scientific rigor. So again, Slack is doubly important because the response time is the optimization goal. And I think this is So the question was, well, what kind of things do you measure? It really depends on what the business is. So in advertising, like my kind of startup experiences were mostly in advertising. That could be, let's say, click-through rate for ads. It could be revenue per user. The most important thing is the ability to formulate the hypothesis beforehand, which could be, let's say, revenue per user stays the same between the test group and the control group, or it increases by a certain percentage because of some factor that you want to attribute that increase to. So specify the hypothesis up front is the most important thing. What that hypothesis is dependent on the nature of the business.
There you go.
Are there any other comments?
I'm just curious, is the hypothesis what drives development, and then you're out in the field testing to see if your hypothesis is true for the product? Is the hypothesis what starts development, and then you're out in the field testing the hypothesis that you just went ahead and produced? Are you answering that question? Is that the idea?
Yes, it is hypothesis-driven. So so let's say when we would develop a feature, we would formulate a hypothesis that it leads to some kind of quantifiable improvement, and then kind of that guides development. So then we figure out what we have to build and how we will measure, what we have to build into the product so we can measure it, and then we learn from the data that collected.
I'm curious about how you would do the build, measure, learn in the embedded world where actual users might be a year or two away from your development. Or is there an alternate, do we define an alternate definition of user in this context?
Yes, I think it would be a different definition of a user because, again, the user of embedded software device running that embedded software would not be the consumer-validated learning. So the consumer-validated learning would be the leader of the organization that makes the device. So this means their learning cycles could be decoupled from the delivery cycles to the actual user. So in our world, which kind of internet app world, which may sound like it's simple, but we have to do this decoupling too. We have users that don't pay anything, then there are customers who pay but don't understand how users use, and there is the founder who learns about how all that works. So the build measure loop focuses on the founder. So it's essentially three processes taking place on different levels and accurately decoupled.
It seems like if your goal is to learn quickly, you actually shouldn't build too much. You should simulate. I mean, wouldn't you want to, instead of building something, show people mock-ups or run experiments rather than actually building or working anything?
Yes, it's a very good point. So we can minimize what we build, and it also sometimes means minimizing the, let's say, amount of test automation that we would build around it. And it also, yes, because that way we can put it in front of users quicker. We would measure and learn faster, and then maybe this whole thing gets discarded, or maybe not, and it has to stay in the process, but we've got more technical depth than we would get otherwise by, let's say, following a more technical depth-averse approach. However, here's kind of slack. I said slack is doubly important, which means you have more slack to retire that technical depth. So generally, I would say as a rule, the system that is optimized for response times, because it has more slack, it's more tolerant of technical depth.
I wanted to mention that I was reading, there was an article in Fast Company just the other day called 5 Lessons for Using Open Innovation to Maximize the Wisdom of the Crowd. And the point of the article is that success stories like Steve Jobs are really, really far apart, and that you can innovate a lot faster the more people that you have giving input to that innovation. And part of that is getting direct information from your customer as often as possible. Thank you very much.